Question number 76. Markovnikov's addition of HBr is not shown by. Markovnikov addition is the property of unsymmetrical alkenes. And if some alkene is symmetrical, then this addition is not shown by them. In these options, if you look at the first option, that is 1-methyl cyclohexene, that is unsymmetrical. Phenylethene is also unsymmetrical alkene. But if we talk about cyclopentene, what is this? The cyclopentene is this. If you look at this, these two carbon are of the similar type. It means this is a symmetrical alkene. And that's why in this case Markovnikov's addition is not visible. And that's why I'll choose it as the correct option. Similarly, if I talk about propene, that is also unsymmetrical. After that, next question I have. Question number 77. Propyne and propene can be distinguished chemically by. If we talk about these two, both of these are unsaturated hydrocarbon. And that's why if you add bromine in the presence of CCl4 to it, there would be the decolorization process by both of them. It means you are not able to distinguish using these reagents. Further, dilute alkaline KMnO4. In this case also, being unsaturated hydrocarbons, they are able to decolorize this KMnO4 also. You cannot differentiate these two. Further, if I talk about H2, PD, carbon, it means this palladium and carbon is added in the presence of hydrogen, hydrogenation process. Both of them being unsaturated are able to give this reaction also. So that's why you cannot use to distinguish them. But if we talk about the reaction of propyne and propene with AgNO3 in the presence of NH4OH, then definitely you can distinguish. How it's possible? If we talk about this propyne, this is this type of compound. While you add the reagent to it, being this H is acidic hydrogen, and it will form the product that is this. But if the similar reaction is done with propene, in this case, what happens? Yes, definitely there is no reaction. And if it is so, you can easily distinguish these two chemically. And that's why the correct option for this question becomes option 3. After that, question number 78. Major product A in the following reaction is. We have this alcohol. H plus ion in the presence of heat is added. It means this is the process of dehydration of alcohol. And that results in the formation of alkene by the process of beta elimination. So in this case, what is going on? First we have this alcohol this way. And in this case, you are adding H plus ion in the presence of heat. So there is the removal of water. How it happens? It happens in this way. First is the formation of OH2, and then there's the removal of H2O, and there is the formation of the primary carbocation. This is unstable. To make it stable, tertiary carbocation is formed, but that is formed by methyl shift. So I'm just writing here, this is the process of methyl shift that's taking place. And after the methyl shift, there is the formation of this is CH3, this is central carbon at which this positive charge will come. After the methyl shift, there is the methyl shift that's taking place. And in this case, there's the formation of, and then this type of carbocation is formed. This is unstable, and this can be stabilized by shifting these electrons here and by the removal of this proton. So this gets changed into CH3, C, double bond, CH, CH3, this is CH3 here. This is the product that you will obtain. This is A, and where this type of product is given here, you can clearly see that this product is given here in option 1. That's why I'll choose this as the correct option. After that, question number 79 is here. Question number 79. Most reactive alkene towards hydrogenation under catalytic conditions is. Most reactive means less stable, and stability in the alkene can be there with the help of hyperconjugation. If you look at the alkene given in option 3, you will identify here that alpha to this double bond, there is only one carbon atom at which one hydrogen atom is present, that is alpha to it. And there is less stabilization by hyperconjugation, due to which it is least stable. While in other compounds you will see that alpha to this double bond, there are the carbon atom at which two hydrogen atoms are present in this case. Similarly, if we talk about this, there are two possibilities for the alpha hydrogen. It means there is more hyperconjugative structure, more stability would be there. Similarly here also. But if we talk about the third option, there is least stability, and least stability results in most reactivity, and on that basis I'll choose option 3 as the correct option. Question number 80. Correct order of boiling point is. If we talk about boiling point, that depends on the molecular mass. But here all the compounds which are given in the options are the isomers of hexane. It means this boiling point is dependent on the surface area. More the surface area, more the boiling point would be. If you look at option 4, you will see that this is normal hexane, maximum surface area, maximum boiling point. Then we have 2-methyl pentane, less surface area as compared to the previous one, normal hexane, that's why less boiling point. And here is the least boiling point in case of 2,3-dimethyl butane. While in other option it is not so, that's why only one option is correct, that is option 4. And this is the correct answer also. After that, question number 81.